Good afternoon. My name is Sam Druker. I'm a development manager on the WinFS project, and this talk is WinFS and ADO.NET, Future Directions for Data Access Scenarios. And I'm going to talk about a few things today. I'm going to talk about balancing innovation and continuity in our technology space, particularly in the areas of data access, integrated storage in the WinFS project, and how that relates to the general purpose programming model for databases in the large. The patterns and techniques and query infrastructure that I'll show you today are most properly thought of as an evolution of ADO.NET in that it represents the forward-thinking vision of what data access and database programming looks like for the future. And by the future, I want to be very explicit. This is not code that you can take home in WIDBE. This is not code you can take home in WinFS Beta 1. These are patterns, query languages, and tools that are in the future with respect to that. They're not stuff that you can take home and work with in the beta today, but they will be coming in future CTPs and betas as we move forward. We are going to talk about client-side infrastructure for query commands, mapping, storage mapping, object mapping, type connections. We're going to talk about the language integrated query or the LINQ project. And we're going to show how these patterns all lead up into building next generation applications over WinFS, the relational file system that is the heart of integrated storage. And we'll do a couple of code demos along the way. There are really several factors that feed into this talk. One of them is the bundle of innovation that we had in the WinFS APIs that were part of the storage platform that we showed at PDC 03. And there was a lot of innovation in the programming model for WinFS as of that PDC. There were strongly typed objects. There was a object-flavored query language in OPath that made it very natural to write queries against that rich model for items. There were symmetric file and item update patterns in the API. The connection model had been extended for a file system like connections over path names. There's some other technologies that over the last couple of years have also contributed to the stack of innovation that we've been trying to bring together and integrate moving forward. Some of you have asked me about, hey, what happened to object spaces? We learned some lessons from MBS Entity Persistence Framework. And of course, now we have the LINQ project. And we can talk about how query and strongly typed objects in the programming model need to integrate together to provide a seamless experience. And through all of that, we want to be able to introduce these new innovations in a way that preserves the investment that people have in existing ADO.NET applications, and carefully factors these components so that we're not forcing people to choose to use a lot more of these innovations than maybe they need in their particular application at that time. We're really trying to be very general purpose about how this technology layers out. So just a starting point, data access fills this gap, and it really fills a couple of different kinds of gaps. The first thing that you can think about data access doing is providing you a measure of independence from a lot of the specific intricacies of how different stores represent essentially similar but slightly different concepts. And so the first role that data access has to do is to actually bridge the gap between different storage models. And this is by and large something that data access layers are doing pretty well at. This gap, although we get a new store like WinFS in the mix, and it certainly tests our ability to provide that independence, we're not far off here, I think. The second gap is the gap between how the store considers data and what its programming model is at that storage layer, and how applications are written. And this is a gap that, say, decade over the last 30 years has only been getting bigger. Programming languages have, in fact, evolved quite a bit. In the programming platform that we have today in .NET, particularly with some of the extensions that we're getting in both Visual Basic and C# right out of the bat with LINQ, is getting bigger. And so the plumbing that exists to glue the tremendous innovation in programming languages over that time into the storage engine, in fact, has to adapt to that. And that's a bigger and bigger challenge moving forward. So I'm going to show a really quick demo right up front. And this is almost so trivial a demo as to, well, I'd say it's really Mickey Mouse code. But so what we're going to do here is we're going to write one of the most basic WinFS programs that you can imagine. And what we're going to do is we're going to open a WinFS data connection. Larger. Fonts. There we go. You know, funny things happened when I made it bold. But hey, you guys want bold? We'll go with bold. Is that better? Yes? Does at least one person think it's better? Okay, good. Okay. So we're going to open a WinFS data connection. This is a typed connection in that this thing actually knows about the containers or the tables that we have in WinFS. We're going to go ahead and, from the items container, we're going to bring out the collection of person items that live within items. We're going to go ahead and in that collection, we're going to write a simple link query. And this query is to filter out and show people that are in my item store that have a birth date before 9/14/95, which would make them about 10 years old. How many people went to either of the C# or the Link presentations earlier today? Awesome. How many people did not go? All right, there's a few of you. So very quickly, let me explain Link. Link is a project that has integrated query operations right into the programming language. So when I write person p and people.where, people is a collection. It's a collection of person types as we understand it. Where is a method on that collection that is taking this expression as a predicate, this one right here. That funny C right arrow syntax is something called a lambda expression, and that's just expressing, it's like a mini function that expresses the filter predicate that we're going to apply to the collection. And through the magic of IEnumerable, when that's in the context of a for each, that's actually going to cause a query to be executed. We're going to get the results of that query and print them out. Really, like I said, Flintstone level stuff. Maybe I said Mickey Mouse. I like both of the metaphors. Okay, so it's going to go against the store. And very simply, it's going to print out the 10 friends of mine that I have contacts for that are older than 10 years old. Nobody's going to make the joke about upgrading my friends? All right, fine. So let's make that a slightly more complicated query. And we can do that simply by extending the filter operation that we're doing here. So let's do... let's look for my friends that are also named Mouse. We'll go ahead and build that. And that expression, as you see, is right in the language, strongly typed. I have two mouse friends, Mickey and Mighty. And we'll leave Mighty for another demo. But simply by writing just another expression here in the language, a C# expression, we can extend the power of the filter. And of course, the Link project has a number of query operators. I'm not going to go into detail on that. I believe Anders is doing a repeat of his Link session tomorrow, which would be the good session to go to get the overview of that. And Luca Bolognese is also doing a session on the other side of the dealing project tomorrow. Both of those would be good sessions to check out. Sorry? TLN 306 and TLN 307. I believe I have it later in too. Okay, so why improve data access? If we've got all this great innovation up in the programming language, if people are already writing great database applications, why do this? So I'm going to make a couple of observations. The first observation is that in some sense, what we're trying to do with this collection of patterns is codify existing good practice. There's, pretty much every significant database application today has a conceptual data model somewhere. It doesn't do much with it. You can't leverage it to make development easier. It's often out of date with the actual code. It doesn't really have an incarnation in the schema language. But there is a conceptual data model somewhere that you have to understand if you're going to successfully modify, maintain, and upgrade your application. We should be able to take advantage of that and provide better support for that. more ways to leverage that. Then the second thing is that that gap that I pointed out before between the idioms of the programming language and what we have available from data access or the storage tier has gotten much bigger. And so pretty much every significant application that deals with the database today has some code that builds these ships that, you know, take data from the one tier and ship it all the way up to the top of the tier, and boats that bring it back down. Every application does that, and every application that writes this code, you know, has to maintain this code. Everybody does it a little bit differently. Some people do it in one way for reads, a different way for updates. Some people do it in a way that makes it hard to do good updates. You can buy middleware to do it. Sometimes the query that you get out of that is not very good. So there's lots of good reasons for us to try to build a more standard practice around the programming model to solve this problem. Now, once we dig into those two needs, there's a strong overlap in the demands that we have just for applications that are moving forward today. A lot of applications have to deal with things like schema evolution, versioning support, where they really have a need to be able to map and reshape the data that the program is dealing with, depending on what store it's in. You might have version 2 applications connecting to version 1 stores. You may want to have a specialized framework or programming model for, say, analytical type applications that has a different data model than you use in programming some of your transaction processing applications. That kind of reshaping is very hard to do today. One of the reasons is that it's very hard to get good query support over the reshaped data. So you can certainly build things that do that kind of transformation, but having a real query solution that works through that can transform the queries of the same mapping technology is an area that I think we can have a tremendous impact in. Secondly, we would like to be able to provide these things as a smooth evolution from existing functionality. People know how connections and data readers work, and we'd like to be able to provide it in a way where people can just sort of build on that knowledge and not have to learn yet another whole new API, which I hear is not very popular. Thirdly, if we do these two things well, we provide some basic building blocks for building a more productive development platform. What I mean by that is if we actually have a conceptual data model that has some consistency across different service components, across different applications, then that data model can serve as sort of the lingua franca for services that live close to the data. A little bit of mea culpa here. If you went and built an application that, say, used SQL Server Service Broker, and you built a part of your application that used SQL notification services, you would notice that the shape of data in those two applications were gratuitously different. Not to slam those two products, they're building good products, those are great applications. But the fact that that programming model is not a smooth integration between those things limits the ability of Microsoft, limits the ability of third parties, limits the ability of applications to build services and components that interoperate in a way that allow you to actually build software out of components. And then secondly, this set of building blocks are in fact the same building blocks that we would like to be able to plug into the great new innovation in our programming languages across .NET. So this is the very high level, not yet an architectural slide. I'll divide the kind of capabilities that we're going to talk about into 4 layers, and they really do layer on each other. The first are tables. Tables as you know and love them today. These are rows, they're columns of scalar entities, and they are exactly as we deal with in ADO.NET today, and the programming surface is very much the same. The next set of capabilities that we will layer over that is reshaped data. That is the ability to actually take a flexible storage map, plug in that custom map over the set of tables that you have, and you can get data reshaped according to the map that you've just specified. And again, this goes back to some of the schema evolution scenarios, but it's also the same kind of data shaping that we're going to need to support entities. And entities are the next layer up in the stack. Structured entities you can think of as a richer model for rows. That is, instead of being a set of scalar types, in entities we can actually create things like collections and inline types and relationships and use inheritance to describe our data. And then above entities, finally, we can get to a full-on object programming model. And the object model is a lot like entities, but there are a few more things that you have to do over and above the rich structure that you get with entities in order to actually have the full object set. And there are a couple principles for how these layers work. One is that we really wanted a consistent model for each of those layers. So if you know what to do with tables and you find you have to use reshaped data, or you're already using entities and you'd like to actually just plug in the object model over that, those distances should not be tremendously great. Like, it should be consistent. It should be easy to figure out how to get from one to the other. The second principle in this factoring is that we wanted to present a sort of pay-as-you-go complexity in implementation. So if you don't need a full-on object model, or you need to do some fast and dirty projection work for analytics type application, you can grab entities, you get the strong query support, you can get the rich structured data, but you don't actually have to incarnate objects, deal with hydration issues, worry about projections out of those objects in the update model, and so forth. So this is the slightly more detailed diagram. And again, I'll point out, and you should know by now that the red slides mean future technology. This is the architecture that we're talking about that will support this kind of factoring of components. So we have stores on the bottom. Here we talk about SQL 2000, SQL 2005, and now WinFS. And they plug into ADO.NET data providers just as we think about stores and data providers interacting today. That isn't, there are some extensions to the data provider interface that I'll talk about coming up, but it is essentially the data provider interface that you already know from ADO.NET. Above that layer, we now introduce a thing called the ADO.NET EDM provider. And EDM stands for Entity Data Model. And the EDM provider is the thing that actually provides a couple of the layers that I just talked about. It provides the raw mapping capability in order to provide a flexible storage mapping and do the data reshaping that I just talked about. It also introduces the capability of taking that data reshaping up into complex records of objects that we now call entities. I can't say objects. I sort of run out of nouns to use when I describe this thing. When you actually go all the way up into entities, and I'll explain entities in a little bit more detail in a few slides. Above that, we talk about the object layer. And the object layer is sort of the fully integrated, strongly typed CLR programming model that exists over entities. And again, that takes the rich record. It adds notions of things like identity, update tracking, and caching into the model. We talk about the .NET Language Integrated Query, or the LINQ project, as the query language that exists over all of this and actually plugs into the object support that we provide out of the object layer, so that the expression trees that you can generate with LINQ that execute over these things actually can go through the query transformations that we provide through this EDM provider. And that's what gives you the power of the flexible storage mapping at the same time that you get the query expressions as presented by the LINQ project. I'm not going to talk too much about these two rectangles off to the side. You can imagine there are metadata services that cross these layers that allow you to do things like specify your connection strings, actually give you the repository information for where your flexible storage maps are, et cetera. And the set of design tools, of course, that manage both the metadata and the schema that you produce as a result of these kinds of connections. Okay, so in terms of motivation, there's a set of things that we've heard from various customers. And the WinFS project's been fun, actually, because we've talked to tons and tons of customers who have very wide and wild both expectations of what a database programming environment is like. I've literally gone from one conversation with a Windows programmer who's heard of databases to guys who are building enterprise class CRM environments in the space of 5 minutes. And several different mindsets in between of people who sort of maybe understand databases and are far more expert than I probably ever myself will be. And pulling out the common set of innovations that make database programming approachable and easy for people who are getting introduced to some of these concepts for the first time, all the way up to people who are already building enterprise data applications, we found some commonality, in fact, even in those wide viewpoints. First thing is evolution, not revolution. So don't make me throw out all of my old code that I've already written in ADO.NET, that we've already done in the .NET platform transfer. I want to be able to get these new capabilities and build them on top of the existing code that I'm running in my environments today. There's a set of feedback that we've heard about SQL being the foundation. SQL, as we know and love it, is about 30 years old. And there's a lot of value in the query language, the query model, and the ideas and the training and the evolution and momentum that SQL has as a concept across database programs today. So trying to hide the power of joins, trying to hide the power of basic SQL constructs is definitely not the answer. And then fourth, bridge the gaps, as we were talking about earlier. I promise we're going to get to code in just a second. So basics. ADO.NET today contains a bunch of the basics for database developments. And we're going to start with connections, commands, and the reader. These are ideas that have been around in previous APIs. And of course, data connection, data reader are things that we have in ADO.NET today that build up from some of the same concepts as we built along these same sets of problems before the .NET platform. And they already provide in of themselves a consistent component model. Provider, connections, and commands together form the three basic parts that you need to actually talk to a database from within a program. And then, of course, there's a model over that that extends that for data sets and building collections and doing disconnected model stuff. And I'm not going to talk too much about that today. The core fact that I want you to think about is the fact that this is already a good component model. So ADO.NET today, you can see my little diagram on the right here. We're talking to a relational engine, and we've got those three parts, the connection, the command, and the data reader. Is this code a surprise for anyone in the room? Has anyone never seen ADO.NET programming as it stands today? Cool, okay. Is there anyone who's never written a database program? Okay, just checking. So you go ahead, you open the connection, you give it a command text, you execute the command text, you iterate over the reader. The update pattern is exactly the same. You give it some command text in SQL DML, you execute the command, you close the connection. Okay, so the first subset of these problems that I want to talk about is customers want a better model for queries in the application today. We want to provide real integrated query support up through my application. And as we factor these other technology components in, we want to make sure that we are still providing all the power of a query processor up through the application model. The second thing is that we heard a lot about not wanting to be tied to particular product-specific query syntax. People wanted to be insulated from what they thought of as legacy or non-standard syntactic systems for providing those queries. The third thing was that customers who had opted to use solutions here, particularly OR solutions, were already in the position of not being able to change the fundamental schema for the database of the application that they were working with. Not even to do something as simple as add a view. Okay. So the first extension of this model that we're going to talk about is canonical command trees. Canonical command trees, from the point of view of ADO.NET, are structured abstract representation of queries. They encapsulate expression operators, parameters to those expressions, and in fact updates and assignments through those expression trees. And from the point of view of the plumbing, ADO.NET, they can be produced in a variety of ways. They can be output from the language integrated query operations, as we saw in Anders' talk today. They can be built up from a public API surface for those command trees. This is particularly useful for applications that do some kind of dynamic query building. Those of you who went to WinFS talks earlier today already have seen quite a bit of that. Or in fact can be produced by client-side parsing of textual query languages. Whether that's OPath, as you have in the WinFS Beta 1 today, or we'd shown in previous Object Spaces previews, or say a new version of SQL that was of the SQL language that we had adapted for some of these object-specific navigation and collection patterns, OSQL. The important thing here is that these are structured representation of the queries. So they're not pasted together text strings. They're not generated from a new language. They're language agnostic in that sense. That's what we mean by the canonical part. So now we'll go back to our example, and all we've done now is we haven't added any new components on the right. What we've done is upgrade the data provider interface here to take these canonical command trees going down, and of course the data readers going up, presenting the results in this stack are exactly the same. So now you can see in the second stanza that we're going to build up a query expression, And in this case, we're going to build a query expression by parsing some SQL, select customer from customers where ordered at amount is greater than 100. And that's actually going to get parsed right inside your application. That's going to create one of these query expression trees, and you can use that directly as a command. Now, the other nice thing about these trees is that even though I show it in this example, these trees are in fact composable. So you can actually build up these queries, you can persist them, you can compose them, and you can treat these queries as first-class objects within your application. The rest of the pattern is very similar. You take the customer's object, you set the command. I'm taking advantage of one little more part of magic with programming language integration in the third stanza, which is that the for each declares a data row in customers, and customers implements an interface called IEnumerable for C#, which means that the for each knows how to automatically give us the execution of the command, and we didn't have to write the extra line of code to do the execute. Again, though, we will iterate through the results. The update pattern is exactly analogous. So instead of presenting DML that's going to get shipped down to the store, we actually can take, just as we took the SQL text in the query expression build in the second stanza, we can take the update in a similar way and take that structured update, it's again just another form of the expression tree, and execute that directly, structurally. Now you might think, so what happens to these structured objects, or these structured query expressions? And in a provider, there you have to make a choice. If you have a store that can natively understand the structured object, then you can just pass the structured object down to the database. And you can well imagine databases evolving over time to accept the structured representation, just like they take textual representations today. For providers that are hooking up to databases that don't understand structural query trees, which is pretty much all of them right now, you have to actually take that and with the knowledge of what syntax the underlying store supports, generate a SQL expression that you hand off in the provider and pull the results back from. And of course, at the end, you close the connection again. Now, I made this point about conceptual schema before. And there's a couple of ways you can imagine leveraging this if we can actually incarnate conceptual schema as an important thing for database applications today. One is that you can gain some flexibility in how you manage your storage. You can actually insulate more of your code from underlying database schema that either doesn't fit your application or that shouldn't affect your application. And this is just a continuance of data independence as we know it from before. Does somebody have a question, or did I miss that? The second thing is that we can build tools that accommodate differences in storage layouts. Even if your conceptual schema is going to remain the same, but you're going to tune the storage layout that you use against that, or the storage layout is different from store to store, whether that's versions of the database that you're using or just versions of the storage layout that you're using, that can be accommodated via this flexible storage mapping. And we heard a lot about specifically using this to let analytical type applications use a different conceptual model than the transaction processing applications that were actually feeding the data into the analytics. So we know that we have this set of requirements for being able to flexibly map storage. So the entity data model is the language of that conceptual schema that we're going to map the storage tier into. And I'm not going to present the BNF or go into tremendously gory detail about the type system. Let me just sort of give you a definition of the entity data model by example. In this picture, you can see that customer and order are entities. Customer is a somewhat complex entity. It has three properties: customer ID, company name, contact name. It has an inline type for the address. That means that address is itself a complex record that's sort of nested inside the customer entity. And we have a collection of phone numbers inside the entity as well. So you can see we've got collections, we've got inline types, and this is essentially building up entity to really just be a lot like a row, except with these rich modeling constructs right inside what would otherwise be scalar types from the relational model. The second thing that the data model has is a notion of relationships. And there are two kinds of relationships that we think about when we say that in the data model. The first is an association relationship. And here you can see that order, a basic entity with three properties, is associated to customer. And we would say that it's associated to the customer through this join key customer ID, lazy K. And this is essentially just a schematized declaration of a fairly simple expectation from the conceptual data model. This is really just an ER diagram. It's not that sort of new. The second kind of relationship that we would talk about is a composition relationship. And in this case, order lines is a collection of order lines, which themselves can be thought of as inline types. And it has a composition relationship with order. And what that means is that if you had an order and you were to do something operational to it, like delete it or copy it or move it around, order lines would follow through. It would be serialized with it. It would be deleted upon the delete of the higher order. And that's pretty much it. It's a structural relationship with just those operational semantics. So that is pretty much the complete set of the entity data model. The last thing I would point out about it is that this data model is not much more complicated than the relational model as we already have it in the database today. There's really just a couple of concepts that we've extended that model with. We have the structural concept of the relationships, inline types and collections, and that's pretty much it. So why have a data model? Well, there's a couple reasons. One, I already made this point, but everyone already has a data model. It's not whether that data model came from some enterprise architect that covered a couple walls and big UML diagrams with boxes and arrows and, divined the inheritance relationships of how the tables that got there in the third version of the second acquisition, or whether it was actually an object model that ended up using a real database for persistence in version 2 and understands how to take the graph down in there and uses inheritance in a highly polymorphic way. There's always somewhere that conceptual model of how the nouns in the program actually work together. Once you have actually built that data model, it would be great if you could actually leverage it for things. That would be a good reason to keep it up to date. It would be a good reason to declare it in the first place. And we can provide those services around the data, things like synchronization, unified backup and restore, visualization tools like storage views that we talked about in WinFS. They give you a good reason to rely on that component model. And then lastly, if we're formal about what that conceptual model is, we can provide a strong foundation for the underlying query semantics and the query algebra that goes over that data model. So it's important that we have a good structural model and that we have a closed query algebra over it. Now, most guys other than the database geeks in the rooms may or may not care about that, but we know that we can build good query optimizers and that we can provide good transformation through the flexible storage mappings that we talked about if, in fact, we start with a pretty good structural model. So, I'm sorry, I forgot my last point there. So the model that I just showed you, though, it's important to point out, is really, well, I would say it's an extended relational model. And it's important to note that it is exactly a proper superset of the original relational model. So if you need to use a service that understands entities from our stack, and you're still in the world of wanting to explain rows and tables for your particular application, that's not a big deal. You can express rows, tables, and columns with scalar values in exactly this model. You just don't need to use the richer stuff when you're actually dealing in that world. So in this example, we're going to add two new components, a data connection and a data command. The data connection is the first thing that we'll see. And what that provides you is a connection, just like we got from the ADO.NET Data Provider connection below. And all we're going to do now is we're going to hand it a storage mapping file. Now, I'm not showing you a storage mapping file. Many of you probably noticed that. And in some sense, the plumbing here is not about the syntax of the mapping file that's used, or whether there's 3 mapping files or 2 mapping files or code annotation that's used there. The specific decisions for whatever RTM release we build this for are still up in the air. The important thing is that we know that you can create a connection and you can hand it a flexible storage map. And once you give it the flexible storage map, you are now speaking as it were, in the level of the mapped or reshaped data that you have handed it. So that means that, in fact, that structured query that we just talked about, the nouns, the parameters in your queries are in the language of the reshaped data. So it's not in the level of abstraction of the storage tier. You're not dealing with the names of the underlying storage tables. You're actually dealing with the names that exist in the type system that's defined by the storage mapping. Then we'll create this data command, which looks exactly like the command structure before. We're going to hand it the SQL string. And again, I'm just sort of aligning some of the details here to make this a little clearer. The SQL string, again, uses parameters and then names of the mapped data. And we'll go ahead and execute that. And the update pattern is exactly analogous to what we saw last time. And you can see in the text in this last stanza here of the update command, insert into customers ID last name values 00 Ellis, that customers is in this entity data model. It's in the namespace and the type system of the reshaped data. It's not the underlying name of a storage table. In fact, customers could be mapped to multiple tables. And the storage map is the piece of technology that takes care of figuring out where that stuff goes. So lastly, once you've gained the ability to reshape this data into these rich structures, and you know how to actually program to those structures directly, it's not a far distance to jump up to actually having objects in the first place that you're going to use as your strongly typed object library, your class library that you present for your application or your extensibility environment. And there's a couple of reasons to do that. One is you've heard a lot, especially during the link talks, about the impedance mismatch of database programming, query programming, the underlying storage model. But there's also the business of maintaining your own mapping infrastructure. These storage maps are a declarative way to maintain that mapping, which means that you don't have to maintain some code base that does the mapping, and maybe it does the mapping this way for certain update procedures and this way for other update procedures, or pulls the data out of stored procedures. You can still map to all that stuff in the storage tier, but if you have a declarative map, you can do these kinds of query transformations over the front. So this provides you that sort of end-to-end solution for getting into the language of the programming model. And then finally, here we start to get strongly typed validation of your programming model. So as you saw in the WinFS example, contacts have a CLR class that is the contact, and IntelliSense knows about it, and it knows that the shapes are correct, and you can make assignments, and those things happen well. So in this next layer, which we'll loosely call the object layer of the stack here, we introduce two things, an object context and a data command. And the data command is actually a generic, and that creates a typed query that we can pull strongly typed objects out of. So again, we're going to create an object context. You can see that we built up from a connection to a data connection, and object context is just the next layer of this connection model for the components. You'll notice that I hand it an object map file, and that is to say that our architecture supports the notion of being able to take that conceptual entity space and actually map that to objects in a slightly different way. This is an area of the architecture that we've received some very strong feedback from, but very strong feedback from probably a minority of the customers that we've talked to. But there are some very good uses for it, so we still have this second capability. People use it for things like dropping bookkeeping columns out of the programming model, or presenting say a object model to a scripting language that you were having an IT administrator use with the database or something like that. Now, once you've created one of these object contexts, one of these fancy data connections that actually knows about object identity and so forth, now we can create data readers essentially that are typed. So we take data command. This way, one, we're going to type with customers, and we're going to pull customers out of the customers table, or the customers container in entity speak, and we're going to filter it by last name equals Smith. Those of you who may have played with WinFS or object spaces will probably recognize the where construction and the last name equals Smith construction as actual OPath, which I think is the third query language I've used in the presentation so far. And that is actually going to create this filter. And again, we're going to, in the third stanza, use the magic of the for each I enumerable to actually execute that command. And this time, we're finally getting strongly typed customers out of it. We're not getting row sets. We're not getting storage records. We're actually getting customer objects. Finally, now that we have objects, we also have a much more familiar update pattern, at least familiar from the programming model point of view, in that we can new up a customer object. We can give it the appropriate fields for the constructor, and we can just add it to the object context under the container that we know about. And here, that's, of course, the customers table for the purposes of this example. And there we have it. That has sort of the basic support for objects. Now, there are a couple things that are not great about this example. One of them is that you still have to know that these customer objects are going to go in some container named customers, and you have the opportunity to give that as a string, and you can still mistype that and get that wrong, and you wouldn't find out about it until execution. So we have a little bit of sugar that we recommend for using this. And here we're going to create up this sales data connection. And the nice thing about the sales data connection is that it's a class that has generated for it already a property called customers. And that property, it does exactly the same thing as we saw in the previous example. That is, you give it the create command. The property access that we see in this new pattern is exactly equivalent to that create command where you had to spell out customers, except there's no chance of actually screwing it up because it's just a normal property on the CLR object that is the type data connection. You're still giving it the filter where last name equals Smith. You're still iterating through it in the same way. The update pattern also can take advantage of this type data connection in that it can do salesdata.customers.add, and that will go directly into the table container that we've already talked about. So this is pretty much sugar, but it's important sugar for people who are doing things like application extensibility environments where you really want to maximize the chance that the guy who's using your environment can actually program with your data and program inside your application correctly. So lastly, we're going to get to, I don't know about lastly, I keep using terms like that. We're going to talk about this language integrated query model. And we just saw strongly typed objects without language support. So now we're going to talk about the case for actually providing language support. How many people need to be convinced that programming language support for this would be a good idea? Everyone seen this slide from the Link project? Good. So what we're talking about in Link project is this unified view of query operators common across all of the .NET languages, including an extensibility model to cover languages that we haven't actually built it for yet, anything other than C# or Visual Basic. It actually devolves into three categories of plumbing, if you will, standard query operators so that you can do strongly typed language integrated queries over objects in memory. D-Link, which is the code name for the next generation of ADO.NET, which goes, as you'll see in the various presentations between us, to SQL and to WinFS, as we just saw. And of course, Xlink, which is the code name for the next generation system.xml APIs that take advantage of the .NET language integrated query to provide another great experience over XML data moving forward. So now that we have language integration, and I've already shown you the strongly typed patterns for how to get to the data and how to manipulate the data, our example has actually shrunk quite a few lines. So we're going to, again, take advantage of that strongly typed data connection. We're just going to hand it the config file, which is the reference off to whatever metadata service is holding our connection information and our mapping files. And we're going to actually write the query right in the body of the for each. So now there's real magic. It's not just calling IEnumerable on some type that was provided through the plumbing. It's actually building the query up right in the body of the for each. And finally here, we get away from any textual query language. Customer in sd.customers, there's a syntax for the container, where last name equals Smith. And last name and Smith are no longer in OPath. They're actual identifiers and operators that operate directly in the language. And in the update pattern, it's almost exactly identical. I really didn't do anything fancy when we moved to the update pattern here. So the last set of requirements are, or the next set of requirements are about being able to build frameworks for extensibility on top of your core database application. And this is a set of requirements that we heard from lots and lots of customers. It seemed like just about everybody who builds database apps, of course, needs to have some extensibility environment. in that there's always something that has to take advantage of the data or even the services that are involved in building those original components. And so now what we have to do is we have to make room in this model for providing extended services outside of the basic CRUD and query patterns that I've just shown you. We want it to be able to provide those extensibility environments with all the power of Microsoft tools and components from the .NET platform and from Visual Studio that we have to bear in the problem. And we really want this to be an environment where programmers who are writing these applications have the maximal opportunity to get it right and not, say, issue queries against the wrong table or find errors late bound or issue queries that are going to cause interesting problems for performance in the storage tier. So WinFS is a poster child in this talk for a set of extended services that need to take advantage of these advanced patterns. So the WinFS programming model will be a library of services and schemas built on top of these core infrastructure that is particularly targeted for the client data platform. And so WinFS has a data model, and we talk about items, links, and extensions, which are the core concepts that you would see in a WinFS program. How many people went to either Shashir's or Ramesh's talk about building WinFS applications earlier today? Couple, okay. You saw items, synchronization. We talked about relationships and links. Those things are built up as specializations of this core entity data model that I've shown. So you don't have a separate pattern or a separate set of services that have to do things that are just like the EDM as we've talked about. An item is in fact a collection of entities. A link is a particular kind of association. We haven't talked about extensions much, but it's essentially the same idea. Over those things, they provide a library of services, things like synchronization, sync adapters, conflict resolution, knowledge management, storage views for rich visualization of data on the client, unified backup and restore services, Win32 compatibility, and by that I mean that you can fopen a file stream, stores and shares, participation in the shell experience, full text search, lists and auto lists. The list goes on, but you get the idea. And at the core of it are these everyday information schemas, contact, calendar, message, document, image, which are really standardized types now that's provided as a basic part of Windows. And so now we are going to ask Windows programmers to use these types. And of course, these Windows programmers are going to all of a sudden be database programmers, though they weren't database programmers before, hence the need for all this innovation. And they're also going to present interesting challenges for guys who want to be able to use those standard Windows types in a WinFS store and still connect to traditional databases, get at their rows and tables, and actually have a programming model which deals with both of those kinds of data simultaneously. So the WinFS pattern, and again, this is the futures talk, and in particular, even though there's a WinFS Beta 1 disk that you can get from MSDN right now, that is a step along this evolution, but it's not all the way to where I'm showing it today. These patterns are now built up on the same concepts and the same component technologies that I just talked about for the cases before. And so now we go through, we use system.storage, we create a connection. The connection now takes a path name because, of course, WinFS is a file system, a relational file system. We're going to use the strongly typed data commands to pull contact objects up. We're going to use the strongly typed connection and look in the items container, the items table for those objects in the first place. And we're further going to provide this filter by type, which actually will start to compose a query, not execute, but start to compose one of those structured queries that we talked about that is already going to restrict the scope to contact items that are in the store. And in this case, we're not going to do any further filtering. We're going to go ahead and execute that through the IEnumerable. The update pattern is very much the same. You'll note one difference in the fourth stanza here, which is that contacts, like all WinFS items, have to exist with reference to some container. And this is the underlying folder mechanism, folder-like mechanism of WinFS that gives it a lifetime specification. So we're able to add those constraints in the model, and this is still fairly natural, fairly symmetric to the model that we just saw for things that live in tables and sales data, et cetera. So I'm going to go back to the demo machine here, and I'm going to show a slightly more complicated set of code. How many people went down to the hands-on labs and built a WinFS app in the lab? Anybody? Anybody? You should. It's a great experience. It's awesome. But if you go down there and you do the second exercise and the instructor asks you if you're going to get the extra credit for step 2.5, you're now disqualified because I'm going to show you how to do 2.5 in OPATH, and then I'm going to show you how to do it in the sort of latest and greatest programming model that we just talked about here. So in this model, we're actually going to build up a storage searcher, which is a type that's provided by the WinFS API as sort of the row set type we talked about before. It's this late-bound type that can pull results out. And this is the OPATH. And what this OPATH is going to do is it's going to look through my contact store, and it's going to look for people who share the same birthday in my store, and it's going to create the list of them uniquely. That is, it's going to take out duplicates. And there's a number of ways to approach this problem, but this is probably the interesting way to do it in OPATH. And you'll see we have a yield operator. We use positional parameters. But at the heart of it, we're actually going to go in and take the list. We're going to get another extent of the same list. We're going to filter it through comparing birth dates and disqualifying things with the same item ID. And then from that collection, we're going to actually yield up a single list. So let me set up this code. Okay. So we're still going to go find Mickey and Mighty. And now we're going to find people who share the same birthday. So Porky, Mighty, Roger, Bugs, Betty, Wiley, Roadrunner, and Pepe all share the same birthday, but not Mickey. Mickey turns out to be a little bit older. So this query, which is reasonably complicated, when you bring it into the world of language integrated query over WinFS, looks a little bit like this. And I apologize, it's not all on the screen before. I did change the font. I think this is why I didn't do this before. So here we're still going to create a storage searcher storage record. And there's a specific reason we're going to do that. And again, this is that library type that's provided by the WinFS storage connections. We're going to express the same kind, not exactly the same, but the same kind of join query that we just did, in that we're going to go ahead and grab both of the extents. We're going to project them over these two collections. And then we're going to execute the predicate, which again is going to compare the birth dates and work with the item and disqualify things with the same item ID to get the actual list out. Then we're going to go ahead and select out the names, or I'm sorry, the person objects together with their IDs. We're going to take advantage of the fact that we've used this library type, the storage searcher, and we're going to use this member function that we provide as part of the library yield. Now this is kind of a subtle point, but it is, this makes a very specific point about the kind of extensibility that you can get out of this model. So instead of taking this directly into a collection of GUIDs, we kept it in storage searcher. And the reason that that's useful is we can, in storage searcher as a library type, provide some very specific member functions for very common operations that occur in the context of WinFS schemas. So it turns out yield is something that is very common to do when you're dealing with the kinds of schemas that we produce for end user data in WinFS. And we can provide that operation here, and it's within the extensibility environment that Link provides to APIs like this. So even though we're using the language integrated query for the bulk of this query, we can step here and introduce new functionality as an extension of language integrated query to handle very common cases within our framework. So that's going to go ahead and execute the yield, and then we're just going to project out the list and print the names. And I'll go ahead and run all of these, all 5 of these examples. Okay, and so now we can see that the Link example side by side with the OPATH example, and here we've got the same result. Under the covers, both the Link example and the WinFS OPATH example are compiling to the same kind of canonical command trees that we talked about. They're working over the same kind of data model that we provided in the library for WinFS for items, links, and extensions. And side by side, you can see how those queries compare. And even though this is a somewhat complicated example where we actually provided this extra functionality through the yield operator in the extensibility environment, the link query being strongly typed, being statically bound, I still think is a far more interesting query to write, even in the face of all this real-world complexity that we get from these schemas. Okay, so let me summarize the values that we're talking about here. What we've heard from customers is we've gone through this evolutionary path with WinFS, ADO.NET, and language integrated queries, that we want a better programming model for database apps. We really would like to be able to leverage those conceptual schemas that are really de facto, in existence de facto anyway, give people a reason to really make that de facto part of that qualification go away. People would really like to build apps that have integrated support for queries, not just in the programming language, but really as first-class objects. People are building query builder apps. People would like to be able to insulate from changes in programming or query languages. Being able to use the strongly typed models that language integrated query and the operators in language integrated query give you in the Visual Studio experience, being able to use IntelliSense over the strongly typed objects, over the query operators and the method calls. Those are super, super important. And lastly, this all has to work in an environment which is very common to especially enterprise database applications, where people are really working within frameworks for extensibility. They're not working in 20, 30, 100, 10,000 line apps. They're working in 100,000 line apps, and they're building little parts of that or modules that have to interoperate, be able to use those libraries, and have all of these benefits that we've talked about within the context of extensibility in these bigger applications. That's the bulk of my text. There's a few more places you should go for more information. I mentioned the D-Link presentation. My slide, I think, is actually incorrect. I believe that presentation's tomorrow, so please make sure that you check that before you actually go there on Friday, because you'll miss it. Pablo Castro is giving a presentation on ADO.NET 2.0, the ADO.NET capabilities that we have in Visual Studio 2005. We have the hands-on lab down in WinFS, which embodies a lot of these concepts, and we'll get you started with the WinFS Beta 1 bits. After PDC, there were a couple of talks that you can check out on DVD. Shashir Mehrotra's presentation from earlier today is actually going to be repeated tomorrow, I believe in this room at 5 o'clock. Is that right? Okay. 5:15 tomorrow. Please check for the room. That's DAT 310 or 209. Earlier today was Ramesh's talk on building data-centric applications using these patterns in the Windows Presentation Foundation and WinForms. We have the team blog, newsgroups, Channel 9, the usual community stuff. Please come find us, use the bits. I'll be up here. I'll take questions for another 10 minutes or so. And we'll be in the track lounge tomorrow all day. Thank you. Please do fill out your evaluation forms as well. Anybody want to ask questions in the big group? Or are you anxious to go to Universal Studios? I did not talk about data sets, that's right. And honestly, the reason I haven't talked about data sets is that we are still figuring out how to use data sets in the context of these richly typed objects. So whether data set is the collection of hydrated in-memory objects, just like they're the collection of hydrated in-memory rows today, going forward, or whether we need to have a slightly different extension, we're not ready to sort of talk about that yet. We really haven't decided. Fair? Yeah. Yes. It's a good question. So the question is, do I have to inherit from a particular set object in order to get the persistence that we're talking about? Or is there a way to use objects that you already have from your existing hierarchy? So the answer is that we have some understanding of the plumbing required to make it work for any arbitrary object set that you bring it there. The discussions that we've had with customers that we've previewed this material with has leaned us in the direction of actually going ahead and requiring some derivation from a root type. That seems in 90% of the cases to be something that customers are either willing to live with or really not regarded as a problem in the first place. So I wouldn't say that we've made a final decision on that, but the kinds of services we can offer if we impose that restriction are much richer than if we try to do it for an arbitrary set of objects that we haven't done that with. Yep. Absolutely. There are some very exciting ways to do that, I think. Yeah. We certainly haven't precluded that yet, but thank you for the feedback. That's good feedback. So the question is, because WinFS is a file system, and we are supporting database patterns over it, it's very easy to imagine a scenario where it's easy for people to select vast collections of things and do operations they didn't intend over that. I think that the programming patterns that enable those operations are not surprising. So in terms of someone accidentally programming something that did an rm_star on the whole tree, those kinds of things are very difficult to imagine actually happening with any more regularity than you would have to go off and do that in the file system today. It's the case that I could talk more about sort of the specific WinFS business logic hooks that enable certain kinds of delete protection. That might be a good sort of sideband conversation. But we don't expect those kinds of operations, even though we're supporting this set-oriented stuff, to really be all that surprising to the person who is programming them. It's still the case you have to go do select star, you have to get the big collection back, and you have to go ahead and map delete onto that collection. So. Well, the thing is, WinFS already has, so WinFS obeys the file system security model, right? So if you're in a place where there are items that are ACLed to you, you know, we still are talking about that case that is really just deleting the items that are actually belonging to the person whose credentials the policy is running under. Just like we have ACLs in the file system that would prevent that delete start today. So the WinFS Beta 1 bits that you can get from MSDN that we started distributing a couple weeks ago are not link enabled. The version that I have on this demo machine has got a prototype of our storage expression or canonical command tree infrastructure hooked into the link project, but we will be making that available in a later CTP.
So that's not on the conference.
Right, it's not in the conference bits that you have. Soon though, I promise.
The mapping piece to WinFS to SQL tables, is that an emphasis or a focus of the WinFS team, or is it another team?
So that mapping is sort of a strong focus. So WinFS is really two things, right? It's this next generation relational file system, sort of the next generation of integrated storage. And that is a store that is first being deployed in these client environments. And so the particular mapping that we choose for items, links, and extensions into that particular store is highly optimized for the kinds of client scenarios that we intend people to use it for in the local store. So if you were at the previous sessions and you saw the store spy queries where you do meetings from people, people from meetings I'm having today, or pictures of people I'm meeting with today, those are the kinds of queries that we take as the sort of expected workload for that store, and the mapping that we choose in that store is highly optimized for that. That's a very good question. The kinds of stores that you can map to are probably best served by having a local query processor of industrial strength. So I don't envision hooking this up to a JET database or an Active Directory store or an Exchange store immediately. It is architecturally possible to build query compensation in that middle layer. And starts to sound a lot like OLEDB. In fact, it's the same kind of architecture where we can enable that architecturally, but I don't envision in a soon upcoming release that we'll have that kind of capabilities yet. Good, excellent, good choice. One last question. I perhaps could have made this clear in the talk, but WinFS is sort of a case study of how you would use a particular storage mapping and a particular object mapping to build an extensibility framework. So the fact that we have both a storage mapping and a class mapping really comes from more of our enterprise scenarios where there are people who want to be able to, say, give a DBA, a simplified programming model, to do certain kinds of administrative operations, hide certain kinds of columns and that kind of thing. Most ISV packaged goods application development will probably happen where that mapping between the conceptual model and the object model is in fact identity. That's what we've heard from customers most. All right. Thanks. I'll be in the track lounge tomorrow if anyone else wants to ask.